Okay, so we're working on lesson 3.5, arithmetic sequences or arithmetic sequences. And you did do this, I believe, in 7th and 8th grade a little bit, where you have a line of numbers and you try to figure out what the difference is between those two numbers and then what the next number would be. So the first page is about vocabulary, and then the second page, you're trying to find the next term in a sequence, which a lot of you will be able to do in your head. But then page 3 and 4, we are trying to find a number that is way on down in the sequence, and we have to use a special formula for that. So let's go ahead and go over the vocabulary. An arithmetic sequence is a set of numbers that has a common difference between each consecutive term. And what that means is that from one term to the next, to the next, to the next, there is a common number that you're either adding to or subtracting from to create that sequence. So if you look at this first example, from 4 to 7, we're adding 3. From 7 to 10, you're adding 3. And then you're adding 3 to get 13 and adding 3 to get 16. That is called an arithmetic sequence where you have a common difference of a positive 3. Now, when we hear the word difference, we always think that we're subtracting. But in sequences, that is not the case. It's either adding or subtracting. You're just trying to find the difference between the two. Is it going to be a positive difference or a negative difference? And so then when you look at the next example, from 5 to 4, 3, 2, 1, you're subtracting 1 each time. So your common difference between the two would be -1. So an ordered list of numbers that show a recurring pattern is called a sequence. And a sequence in which a constant number is added to each term to calculate the next term is called an arithmetic sequence. And then the number that is added to or subtracted from each term to calculate the next term, represented by the variable d, is called your common difference. And then I'm going to give you a couple of variables, but once we start working with those on pages 3 and 4, you'll understand what they mean. But whenever you see the variable n, that is going to represent the number within the sequence that you're looking for. So that term's position. So if I'm looking for the 11th term, that means that n would equal 11 because I'm looking for that term. And then the other one, n is the expression used to represent the value at that position. So the n would represent in this the 11th term, and a is the variable in front of that. All right, and then the formula that you use is called the recursive formula. Okay. Any questions? Yes.
I don't get what the A and the N is.
So, okay. This right here represents what you're looking for. Okay, so the A represents the or the N represents the term that you're looking for, A you're solving for. So A to the N just means that that's what your next term is going to equal. When we start using it, it'll make a little bit more sense. But let's go to page 2. Now, we are going to look, we're just going to start with the examples. The first thing that you always want to do is find your common difference. Okay, so what I am doing from 3 to 6, and then 6 to 9, and then 9 to 12, I am adding 3 each time. Okay, so my common difference, or my D, is a positive 3. And if it's positive, you don't have to write positive. Okay. Now, the next term in the sequence, that because we're trying to find the next term, is represented by a with a subscript of 5. So that is the term that we're looking for.
What the 5?
Yeah, what the-
Sorry. This is term 1, 2, 3, 4. So we're looking for the 5th term right here. So that's where the 5 came from. And so what we have to do is we have to take the last term 12 and we have to add 3 to it. And so the 5th term equals 15. And so when you're doing your homework, I want both of these. I want your common difference and I want the term that you're looking for, whether it's the next term or term down the series. Okay. Well, let's go ahead and move on to example 2. So from 2 to 6 to 10, what are we doing each time?
Subtracting.
Yeah, we're subtracting 4. And then we're going to we're looking for the next term. So this term right here, for term 4 this time. So our common difference is -4. And then we're looking for the 4th term, which is going to be -10 minus. Okay. And so a to the 4th is a -14. So the next term in the sequence would be 14. All right, we're going to do one more together. We're going to do example 3, and then you're going to do 4, 5, and 6 on your own. So from 1/4 to 1/2 to 3/4, what are we doing? We're adding 1/4 each time. So our common difference is 1/4. And we are trying to find 1, 2, 3, the 4th term. So we have a subscript of 4 is going to equal 3/4, our last number, plus 1/4, which gives us 4/4. And we simplify that down to 1. Okay, are there any questions on how to do those 3? Okay, so I'm going to go ahead and pause the video. You guys can work on these, check your answers with a partner, and then when we come back, you will be able to check your answers. Okay, we're back, and I'm going to go ahead and show you examples 4, 5, and 6 so you can check your work. Make sure you understand this part, finding the next term in a sequence. Are there any questions? Okay. We are going to go ahead and go on to page 4. On page 4, on the practice ones that I do with you, I do want you to write the blank formula, and I'm going to go over that right now. So whenever we're asked for a number that is way down in a sequence, instead of, say we were asked for the 11th term here, for example, 7, instead of adding on, let's see, 1, 2, 3, 4, 7 more times, there's a formula you can use to plug in the information you know and find that 11th term. Some of you may say, oh, it's not that hard to add that many times, but what if you're asked for, like on example 12, for the 31st term? You definitely don't want to do that 20-something times, right? So this is the formula that we're going to use right here. And in the formula, you are going to be substituting values in for a subscript 1 right here, the n, and the d. Okay, so this a subscript 1 is the very first term in your sequence, and because that one can kind of remind you of that. And then the n is the term number that you're looking for. So in example 7, 11 would go where that n is. And then the d stands for the common difference. So you're going to take the first term and you're going to add it to the term you're looking for minus 1 times the common difference. So let's go ahead and I want you to write out the blank formula right here. So it is A subscript n equals A subscript 1 plus, and in parentheses, n minus 1 times D. And I always put parentheses around my D so I don't forget that I'm multiplying these two together. Okay, so let's plug in what we know. So this 8 right here is your first term. So we will plug that in right here. But we also need to find our common difference. Our common difference from each one is +7. So this is our common difference. And then the n, that's the term you're looking for. So 11 is your n. Term you're looking for, the first number, and the common difference. So let's plug these values into the equation. So we have A with a subscript of n, and n is 11. The first term, 11, plus, in parentheses, the term you're looking for, which is 11, minus 1, close your parentheses, and then we're going to multiply that by the common difference of 7. Yes.
Is the first term not an 8?
It is an 8. Oh, an 8. I'm sorry. Thank you. Thank you. The first term goes right here. No, no, no.
The other.
Oh, my word. Okay, hold on. I am. Okay. Sorry, guys. Okay. So now we are going to solve this. Make sure you're following order of operations. So we have to do what's in the parentheses first. So we get 8 plus 10 times 7. Don't add your 10 and your 8. You're going to multiply. That's following the order of operation. So we have A11 equals 8 plus 70. Now we can add to get our 11th term. That should be 87. I mean, oh my goodness. Wow. Yes,
Are you
70.
okay?
I don't know. Okay. Sorry, guys. All right, I'm going to do examples 9 and 11, and then you're going to do 8, 10, and 12 on your own. So let's see if I could do this one a little bit better. Okay, so the 8, we're looking for the 8th term, so that represents n. -15 is our first term, so that is our A subscript 1. And then our common difference is, anybody? +3. Yep. Okay, so let's see if I can plug this in right. I'm going to write out my equation first. So my n is 8. I have that. So I'm looking for the 8th term. My first term is -15. I'm going to add that to the 8th term minus 1 times my common difference of 3. All right, do I have that right?
Yes.
All right, thanks. So now we're going to go ahead and solve. Make sure you solve in parentheses first. Then you solve your multiplication. And you solve your addition. Are there any questions on how to plug your information in, how to solve it, anything like that? What anything means? Okay, I'm gonna do one more with you, example 11. So 12th term, 12 is my n, 23 is my first term, and my common difference is 8, -8. Make sure you put that negative in front of it. So the term I'm looking for is the 12th term this time. My first term is 23. And I'm going to add that to the 12th term minus 1 is our common difference of -8. Follow your order of operation. I have 23 minus 88. My 12th term is, anyone have it? Yes, -65. All right. So now it's your turn to practice on your own. 8, 10, and 12. So I'm going to pause the video and we'll come back and check them in just a minute. All right, so here is 8 and 9. Are there any? Oh, wait, hold on. Let me make sure I didn't. Yes.
Isn't 10, 26, or 36? Oh, no, never mind.
Okay.
What, I got -155.
Uh-oh.
Wait, where'd you get, why'd you?
Okay, and here is 12. Any questions before we move on? Okay, let's go to the 2-word problems on the back. And on the back, we are going to read this first, and then we're going to figure out what information we know, what we have to know, and how to plug it all into our great equation. So it says Matthew bought a tablet for $500. He also began paying for a cloud storage subscription for $3 per month. After 3 years, how much will he have paid for the tablet and the subscription? So we're trying to find, we have a sequence here. Every month, $3 is being paid towards this expense. And that $3 is happening every time. So that would be our common difference. Where is what term are we trying to get to? Well, we're trying to get to the end of 3 years. So 36 months. All right. And they're starting off with 500 plus 3 to start off their subscription. Okay. So we always need the nth term. We need the first term, and we need our common difference. So our nth term includes, or I'm sorry, our first term includes 503. Because when they're buying it, that's what they're starting with. Okay. 503 would be the first term. All right. The term that we're looking for, the N, is after 3 years. So we're going, and because they're paying monthly, we have to convert that 3 years into months. So our nth term would be 36. We want to know how much they paid at the end of 36 months. And then the common difference, well, he's paying a subscription of $3 per month. So it's a positive 3. Okay. We're going to take actually, this would be the common difference. Plus 3. So we're gonna take this information and we're gonna plug it into the formula. So I'm gonna write it out. And we're gonna plug it in, and then we're gonna figure out at the end of 36 months, how much do we actually pay for this? So our first term is 503 plus our nth term that we're looking for is 36 minus 1. And then our common difference is 3. Okay, so go ahead and work that out. Oh, I messed up. I put 3 minus 1 instead of 36 minus 1.
I think 3 minus 1 or 36.
36, I messed up. Don't forget your units at the end. So at the end of 36 months, should have paid that amount, $608.
You have to put the dollar sign on there.
Yes. Because it's units. Okay, last problem. This one's slightly different because we're subtracting. We have a common difference that's negative. And our first term, that changes our first term a bit. So an inhaler contains 18,000 micrograms of an active ingredient. Each time the inhaler is used, it dispenses 90 micrograms of the active ingredient. If a patient used the inhaler 15 times, how much of the active ingredient is left? So we need the term we're looking for. We need what we started with, and we need the common difference. Now, in the first problem, because the common difference was adding, we took the original amount and added the 3 to it, right? Well, here, every time you use the inhaler, you're losing or subtracting 90 micrograms. So that means that our starting amount isn't 18,000, but it's 18,000 minus 90. And so 18,000 minus 90, this would be our starting term right here. And 15 is our nth term that we're looking for, and 90 is our common difference. It's a negative 90. Okay, so we're looking for the 15th. And instead of 18,000, we subtract 90 from that, and we get 17,910. And our common difference is a negative 90. So are there any questions how we got those numbers? Okay, I'm going to have you plug that into the formula and solve it, and then we will come back and check it. Okay, so that is the answer. Go ahead and check that. So that you'll be able to start on your homework for this lesson. So that concludes lesson 3.5 on arithmetic sequences.